Chapter 8 Review. Quadrilaterals. Notice we have a little bit of a Venn diagram here illustrating the relationships between each of the quadrilaterals. We've got a trapezoid, isosceles trapezoids, which are special trapezoids. Then we have kites and parallelograms. Notice each of these are parallelograms, squares being the most specific, rhombuses and rectangles being independent, and then we just have these random quadrilaterals on the outside that are not special at all. Wanted to copy and complete the statement. The blank of a trapezoid is parallel to the bases, and that would be the mid-segment. Remember, we have a trapezoid, we have two parallel sides. Those don't look exactly parallel, but it's that segment in the middle, and it needs to be parallel. Something of a polygon is a segment whose endpoints are non-consecutive vertices. That's the diagonal. Connects two non-consecutive vertices. Describe the different ways you can show that a trapezoid is an isosceles trapezoid. Well, you can confirm that this segment is congruent to this after you've first proven these are parallel. That is one way. I'd like for you to come up with some other ways on your own. Match the figure with the most specific name. Notice we have four congruent segments and they're all parallel. It doesn't tell us these are 90 degrees, so the only thing we can say is this is a rhombus. This is 90 degrees and congruent, so this is a square. And all we have here is that this is a parallelogram. It doesn't tell us that it's a rhombus or a square, so this is B. The sum of the measures of interior angles of a convex regular polygon is 3,960. Now remember, the formula for the sum of the interior angles is 180 times n minus 2. So you just do your algebra. Fortunately, I have to get my calculator. Here we go. 3,960 divided by 180. That is 22. 22 is equal to n minus 2. If I add 2 to both sides, n is equal to 24. What is the measure of each interior angle? Now, that's the number of sides. If this is the sum of them and this is a regular polygon, then each of the angles are congruent. So I just take the 3,960 and I divide by the number of sides, 24. So 3,960 divided by 24, and we get 165 degrees per angle. Classifying the polygon by the number of sides, this is a 24-gon. Find the value of x. We need to use the formula 180 times n minus 2 to find the sum. We also have the sum here that we can add up. Now I'm going to add up each of these values, leaving alone x because I cannot combine it. So I'm just going to add each of these up. That's 90 plus 120 plus 97 plus 130 plus 150. I'm going to check over my work. 120, 97, 130, 150, and I'm good. So that's 587. Now, it says n right here, but I know what n is if I just count the number of sides. 1, 2, 3, 4, 5, 6. So I can go ahead and plug a 6 in for this because this is a hexagon. I'm going to go ahead and chug out the left side. That's 180 times 6 minus 2, which is 4. 180 times 4 is 720. 720 minus 587 is 133. 587, so x is equal to 133. All we have to do is find the value of x. Same situation. You go ahead and skip ahead, pause the video, try this problem, and skip ahead and see if you get the same thing that I do. So we have 7 sides. I'm going to check this. 6, 7, 180 times this. Let's go ahead and add up all the numbers. 160 plus 125 plus 110 plus 112 plus 147. 654. This is plus 3x. Chug out the left side. That's 900. Okay, 900 minus 654 is 246. And divide by 3. I get x is equal to 82. I'm going to check over my work real fast. We have 7 sides, 1, 2, 3, 4, 5, 6, 7. 7 goes in there. Add up all these numbers, which I'm going to assume my arithmetic is correct, and then it's just the algebra. Next one, the sum of the exterior angles of any polygon is 360. Notice if I just add this angle, this one, and this one, I've got to get 360. So this is equal to 18x. Now 36 divided by 18 is 2. So that means this is x equal to 20. In a regular nonagon, now this is a 9-sided gon, the exterior angles are all congruent. What is the measure of one of them? Remember, the sum of the exterior angles is 360. Well, if there's n number of angles, then it's just 360 divided by 9, which means each angle has a value of 40 degrees. Here, we're talking about parallelograms. Diagonals bisect each other. That means that m is equal to 10 and 8 is equal to n minus 3. That means that n is equal to 11. Over here we have c plus 5 is equal to 11. And that means that c is equal to 11 minus 5, which is 6. And then we have d plus 4 is equal to 14. If I subtract 4 from both sides, I get 10. Opposite angles in a parallelogram are congruent or equal. Their values are equal. So if I take 103 and subtract 16, I get 87. So b is equal to 87. 18 is equal to a minus 10. That means that a is equal to 28. PQRS, PQ is equal to 5 centimeters, QR is equal to 10 centimeters, and PQR is 36. Sketch PQRS. I'm not too concerned about getting this to scale. I'm just getting something drawn out so I can get going. Now it tells me that angle Q is 36 degrees, so I'm going to call that the acute one just to keep it consistent. And as long as I go around the polygon or the parallelogram, it should work out. All right, PQRS, PQ is 5. QR is 10. Now once again, I'm not concerned about scale. Angle PQR is 36. Is it sketch PQRS? That's what this is. Find and label all of its side lengths and interior angle measures. Now if that's 36, this is 36. The consecutive angles of a parallelogram are supplementary. That means 180 minus 36 is the other side. 180 minus 30 is 150, minus 6 is 144. So this is 144, and this is 144. Opposite sides of a parallelogram are congruent.